Hello everyone, thanks for checking out my video. It's Goose coming at you with a guide on how you can earn Flux by running your own Raspberry Pi node on the Flux network. Stay tuned. One of the coolest features of the Flux network is the fact that it's fully decentralized. From miners to node operators, there are literally thousands of nodes operating on the network, providing valuable compute resources for different projects like Cadena, or Presearch, or Firo, or even Zelcore's rate servers and block explorers. There's really no limit to what you can do with the Flux network. And what's exciting in the new year is that we're making it possible for people to run more entry-level servers, and that would include single-board computers such as the Raspberry Pi, this little guy right here. And the cool thing about using a Raspberry Pi is that it has enough power to run a Cumulus node on the Flux network. So I'm going to take you through the type of Raspberry Pi that you will need, as well as some suggestions for cases and solutions for connecting an SSD. Then I'll show you how to install Ubuntu Server on it, install FluxOS, and sync it to the network. From there, it's up to you. The sky is the limit. You can get a whole cluster of these and run them out of your house if you want, and you'll be earning Flux rewards for doing it. Let's go. The Flux team has a bunch of different resources available to help guide you through this process, and this is a Medium post that was written by Walter, who's one of the main developers on FluxOS and Zelcore. So he's put together a step-by-step installation guide for all of the Raspberry Pi users out there. I'm going to walk you through most of that process here in the video, but we'll also be referencing this article for the lion's share of the steps that we'll be taking to install the software and get everything running. The other article that's good is this Light Node Setup article by Ali Malik. Now, this is one that has all of the steps that you would need to create a VPS or even build your own computer and then install Ubuntu on that along with the Flux operating system. So we'll actually be using a combination of both of these guides. I will leave links in the description so that you can follow along. Over on the Raspberry Pi website, we can check out the Raspberry Pi 4 tech specs, and that includes a Broadcom BCM2711 quad-core processor running at 1.5 gigahertz, as well as 2, 4, or 8 gigabyte variants for the RAM. Now, we're going to need the 8 gigabyte variant because that is the minimum amount of RAM needed to run a Cumulus node. So when you make your purchase of the Raspberry Pi 4, make sure it's the 8 gigabyte variant. Our next consideration will be what type of case we use for our Raspberry Pi. Now, a lot of times when you buy a Raspberry Pi, it'll come as part of a kit that includes a case, but sometimes that case is just plastic and it doesn't really offer much in the line of cooling. So you're going to want to look for an upgraded version of a Raspberry Pi case that will give you a better cooling solution, because this is going to be on full time, and that means that the CPU is going to be getting use. So you're going to want to have a decent cooling solution attached so that it doesn't shut down due to overheating. And if it shuts down, then you're not going to be earning any rewards, right? So the kit that I purchased actually came with this little aluminum case, which I thought was nice, and it includes a little fan. So the only downside of this particular case is that the heat sinks don't really make contact with the aluminum itself. So it doesn't really make for the best heat transfer. So there's that limitation there. Yes, the fan will help, but I don't really see this as being a much more robust option than even the plastic, honestly. You could find plastic cases with fans in them. And not only that, because it's so tiny, it doesn't really have an SSD solution. So I'll be stuck having to use some type of external drive enclosure with a USB 3.0 dongle. So I don't know if I like that as much. I did some more research. I came across the Argon One M.2 case for the Raspberry Pi 4, and I really love this case. It's a little bit bigger. It comes with its own daughter board that offers additional connectivity, including a power switch, and the front has LEDs so that you can see whether the thing is on or not, or if there's hard drive activity, which is really cool. The whole top is aluminum, and it has a direct connection to the CPU and the RAM. So it really works well as a heatsink. And then in addition to that, it has a fan, which is variable speed depending on the temperature of the CPU. So I think with this kind of solution, you'd be more than covered when running a FluxNode. But the best part is the fact that it comes with that little M.2 tray in the bottom. So you've got single board computer, teeny tiny little form factor, and it just makes sense to use an M.2, right? Why have all kinds of external stuff when you can put it all neatly in one package? So for $45, this really seemed like a good deal. The only caveat with the M.2 is that you need either a B or a B and M key style SSD. Now, typically those are the older versions that are SATA 3 M.2s. And if you want to tell the difference, you can look at the connectors. You'll see the B and M key connectors have 3 little connectors at the bottom, as opposed to the newer NVMe or M key style connectors, which is just 2 connectors. Okay, so a little bit more research on that will show you that a B&M variant M.2 SSD will cost you $30 to $35 for 256 gigs. So pretty good deal. And like I said, it'll fit perfectly within this Argon One case. The only other thing about the Argon One case is that since there is a fan and a power switch, you do have to install an additional script to get those to function properly. So if you decide to go with this solution, I will include that step in this video. Otherwise, if you're just going to use another solution like this little guy, just skip that step. Once you've figured out what you want to do about your Raspberry Pi and what enclosure you're going to put it in, we're going to need to download the software that we're going to run on the Raspberry Pi. And for Flux, it's compatible with Ubuntu Server 20.04. So I would recommend going over to the Ubuntu website and then going to the download section where it says Raspberry Pi. All right, and then you'll see an option to download Ubuntu Desktop, or if you scroll down a little bit further, we've got Ubuntu Server, and that's the one that we're going to use, Ubuntu Server, okay? And you can download the 64-bit version of 20.04.3 LTS. LTS is long-term support. It says this has 5 years of long-term support until April 2025. So that's the one that we would recommend that you use at this time. Download the 64-bit version and save that to your hard drive. After your download is complete, it'll take you to this page here where it will give you some installation instructions. So if you've never done this before, this is a great way to go. Just follow the instructions here where it says how to install Ubuntu Server on your Raspberry Pi. So if we click on this, it gives us an overview of all the different things we'll be doing, including flashing the SD card with the software, and then setting up internet connectivity, and then actually booting up the unit for the first time. Now, as far as preparing the SD card, they have a program that you can download that makes it really easy to flash the USB SD card. And you can get this for Ubuntu, Windows, or Mac OS. So it's cross-platform and pretty easy tool to use. Once you install it, then you'll just go through the motions of choosing the operating system, choosing the storage, and going through all of the prompts here and then clicking the right button, and then it will transfer that file that you downloaded over to the actual SD card. After that, you have a question of whether or not you want to use Wi-Fi or Ethernet. If you want to use Wi-Fi, that is a possibility. Although we don't recommend that because with Wi-Fi, it's sometimes sporadic. Sometimes the bandwidth is not where it needs to be. It could be that if you have several devices running in your house, that the bandwidth is somehow limited. You could also have dropped connections. So we need reliability with these nodes. So we highly recommend to use an Ethernet cable. There is an Ethernet gigabit port on the Raspberry Pi itself, so it's best to connect it directly to your router using an Ethernet cable. But if you must use Wi-Fi, then you can go through this process here of configuring your Wi-Fi by going into the SD card and adjusting the Wi-Fi name and password so that it will be able to access your network when you boot it up for the first time. You'll need internet so that you can download new packages and install FluxOS. But without Wi-Fi, plug in the Ethernet cable and you're still good to go. All right. After that, then you would just boot your Ubuntu server, and your first boot would be on a little setup where maybe you have a monitor with an HDMI cable connected directly to your Raspberry Pi, and then also a USB keyboard so that you can type in some commands. To flash our SD card, we're going to need a little device like this USB 3.0 card reader. And that way we can just plug our SD card in and plug the device into our computer. Then we can just use whatever software we want to flash the Ubuntu Server image to the SD card. One little note about the size SD card you're going to need: make sure it's at least a 64 gigabyte card, because if you have anything less than that, the FluxOS database files may fill it up too quickly, and then the FluxNode won't run anymore. So the team recommends at least 64 gigabytes, and if it's possible and you're going to be running this node for a long time, then you might even consider a 128 gigabyte SD card. Now, unfortunately, I don't have either of those on hand, so I'm going to have to use a 32 gigabyte card. It'll be enough to show you how to do all the steps in the video, but just know that you're going to need at least 64 gigabytes. Since I'm using Linux, I chose to use a package called Balena Etcher to flash my SD card. So it works pretty much the same as the tool that's provided by Ubuntu, and this is one that I already had installed on my computer, so I didn't have to install anything else. If you want to use this particular app, you can find it in most package repositories on Linux, but if you're a Windows user or a Mac OS user, then just go ahead and download the tool that's provided on the Ubuntu website, and that'll do exactly the same thing as what Balena Etcher does. Now that our SD card is flashed and ready to go, it's a good time to go ahead and stake our Flux collateral in the Zelcore wallet. We will need 100 confirmations before we'll be able to start our node, and this will give us a really good head start. So to stake, it's very simple. Just go ahead and choose whichever wallet you'd like to use. I'm just using the mining wallet here. And then go to Manage Assets, Add Assets, and make sure you add Flux. Once Flux has been added, then you can go to an exchange and send your Flux to this address. Once you have the Flux, then all you have to do is send yourself a transaction for the exact amount needed for your collateral. Now, to do that is pretty simple. If you want to send it to yourself in the same wallet address, all you have to do is click on Receive and then click on your address to copy it. Then go over here to Send. You can put in your two-factor authentication, verify, and then where it says address, just Control-V, paste your address in, and on the amount line, go ahead and put the amount that you'll need for the collateral. Then click on Send, and that will send you the exact amount to the same address. And from that point on, Zelcore will automatically detect it and lock it up as collateral for your node. So now that we have that done, let's go ahead and start building this thing. One last thing about this Argon One case, especially with this new M.2 attachment for the bottom. The old Argon One case bottom used to have a little opening where you could access the SD card, but this bottom does not. So if you're going to use this particular case, make sure that you flash your SD card and insert it into the Raspberry Pi before you put the bottom on. Or if you're using a more traditional case like this one, you'll see at the bottom there it's got a little slot, so it makes it real easy to insert and take out the SD card. And if you do choose to go this route, then I might suggest something like one of these little M.2 cases that has its own little dongle to it. And while it may not be super practical or super nice like the Argon One case is, it's all in one unit here, it will get the job done, okay? And you'll still be using USB 3.0 connection into your Raspberry Pi to get the faster SSD speeds. So with that out of the way, now that we've got this all assembled, let's go ahead and power it on. Okay, moment of truth. I'm going to turn the power on and we'll see if this thing boots up. Okay, now we have a login screen, and what you're going to need to do is type in the username Ubuntu, followed by the same password, which is Ubuntu, all lowercase. All right, and because this is our first time logging in, it requires us to change our password. So what I'm going to do is type in the current password, which is Ubuntu, and then put in a new password. Okay, now we're in. This is our main command prompt, and the first thing we're going to want to do is verify that OpenSSH is installed. So just type in sys systemctl space status SSH. Okay, and it says that it's active running, which is good. So that means on our network, we can log in to this particular node. So all we have to do is figure out what the IP address is for this node. And to do that, you just type in IP space A. And that will tell you your IP address. Okay, I didn't have my Ethernet cable connected properly, so let me type that in one more time. And there we go. So line 2, where it says ETH0, you'll see just underneath of there it says iNet, and then I've got an IP address there, 192.168.10.106. So that will be the IP address that I try to log into via SSH. Now that we're done with the initial setup process using an external monitor and keyboard, it's time to try logging into our Raspberry Pi from another computer on the network. Now, if you're running Windows, you can do this using a program called PuTTY, which is a free program you can download, and that's a simple terminal emulator. So you would just pull open PuTTY, put in the IP address for the node or Raspberry Pi, and then go ahead and hit enter, and that will ask you for a username and password to log in. I'm using Linux, and if you're using Mac OS, it's basically the same. You would pull open a terminal emulator like I have here, and then just use the SSH package to log in. So to do that, I'm just going to type in SSH space and then our username, which is Ubuntu at, and then the IP address of the Raspberry Pi. And mine ended with 106. All right, hit enter, and now it'll ask for a password to log in. This will be the password that we just changed. And now we're logged in. So there's a few things we'll need to do before we can start installing the Flux software. And among those is to install updates. And the nice feature about Ubuntu Server is that it has an automatic update feature where it will download the latest security patches for the OS, and that may already be ongoing. If not, then don't worry about it. The install script for the Flux software will do this for us automatically. In the meantime, what we're going to need to do, especially if we're using the Argon One case, is install the drivers for the fan. Okay, so in order to do that, there's a command, and I'll leave that down in the description so you can very easily copy and paste that in. And this is the command. All right, we're going to pull a file from the Argon 40 website called argon1.sh, which is a script file, and run it. So once I hit enter, it will download that file and begin running it, and that will take care of installing all of those software packages needed to control the fan inside of our new case. Again, this only applies if you're using the Argon One. If not, then just skip this step. After that, then we're going to reboot our Raspberry Pi, because if you're using the Argon One case, then you're going to hear the fan at full speed, and in order to fix that, you're going to have to reboot it. So simply type in this command, sudo space systemctl space reboot, and hit enter. After the Raspberry Pi reboots, we'll need to log back into it, and the next step is to prepare our SSD so it can be used by the Flux operating system. And right now, the SSD has not been initialized, it's not been formatted, it doesn't have a file system on it, so it won't even be recognized. And to get it ready, what we'll need to do is list it first and figure out which device name Ubuntu gave it, so we know how to, run the next few commands. So to figure that out, just type in sudo space fdisk space -l. All right, and that'll give us a whole bunch of different information here. And what we're looking for really is the size, right? So if you look at these devices where it says MMCBLK0P1, the P means partition, right? So we have a partition here, we have another partition there. That's a formatted disk. So this disk is actually being used. If we look at the size here, 28.5 gigs, looks as though that is my SD card. So that's where our operating system is, right? But that's not the SSD. If I go down to where it says dev/SDA, now I've got 238.49 gigabytes, and that's more like it because I got a 256 gig SSD. So here it is, but notice there are no P1 or P2 or anything like that next to the SDA. All it is listing is that it found this disk, but that's all we got. Okay, so now we know what we're dealing with here. It's /dev/SDA. Now what we need to do is type in sudo space parted space /dev/SDA. Okay, now we are inside the parted configuration program, and this is where we're going to do our formatting, and then we can later on create a file system. All right, so what we're going to want to do is type in the command mklabel space GPT. All right, and this is going to use the GPT partitioning scheme for this particular drive. It's really specific to Linux anyway, but you could use MS-DOS if you wanted, but I think for all intents and purposes, we're just going to use kind of the Linux standard here. Next, what we want to do is set our primary partition. So what we're going to do is type in make part space primary, and we're going to set the starting sector at 2048 S space 100%. So that basically means we're going to start our partition at basically the second megabyte and then go 100% of the space. All right, it's going to say, do you want to go with this? Ignore, cancel. We're going to ignore. There we go. Okay. So that should pretty much do it here. If we hit the letter Q, then we can leave. And now what we'll want to do is type in our fdisk command one more time. So sudo space fdisk-l. And now you'll see at the bottom here, our device is /dev/SDA1. That little 1 there means that we now have a partition, and it starts at this block, 2048, and goes the full length of the whole drive, which is 238.5 gigs. So we're in good shape in terms of the partitioning. Now what we got to do is create a file system. Okay, to create the file system, we're going to go ahead and use a command called makefs. All right, so type in sudo space mkfs dot ext4. All right, and we're going to use the ext4 file system because this is one of the most common file systems and it'll be easily recognized. And then we're going to hit a space, put /dev/sda1 because that's the partition that we want to create that file system on. Okay, looks like that's done. Created the journal and superblock's done. Now we are formatted with a proper ext4 file system and our SSD is ready to be used. One last thing to do is to mount our SSD. So what I want to do is switch users by typing in sudo space su space dash. All right, and now it says root at Ubuntu, right? So that means I'm on the root user account. And the next thing I want to do is just do a quick ls. Oh, I'm in the wrong. I'm going to do cd / that'll take me to the root directory, and then type on ls. And let's check in the media folder. So cd media, and take a look. There's nothing in there right now. Now, sometimes Ubuntu will automatically mount media that has been inserted, but that is not the case here. So we are going to have to do a little bit of work to make that happen. All right, so what I'm going to do is create a new folder here, and I'm going to do that by typing in the command mkdir space, and then I'll just call this SSD. Okay, and then if I do another ls, there's an SSD folder there. And the next command I'm going to type in will be to mount our SSD to that particular folder. All right, so that whenever I go to that folder, I'll actually be accessing the files on the SSD. So to mount this right now, what we'll type in is mount space, and then our directory for the device, which is /dev/sda1. That's our partition. Space, and then I'm going to give it this media/SSD, and that should do it. Hit on enter. Okay, and then if I do an ls and go over here to SSD, now I can hit ls and it says lost plus found, which is an automatic folder that's been added to our SSD. So now we are accessing the SSD. Perfect. The only problem with this setup is that I would have to type that command in every single time I reboot my Raspberry Pi. So how do I get this so it mounts this drive automatically every time I reboot? Well, all we have to do is edit our fstab file, and we're going to put in a new line there that will automatically mount this drive upon startup. First, we need to discover what the UUID is for this drive. So I'm going to type in blkid space, and then the device, SDA1. Okay. Now that command gave us the partition, which is SDA1, and what we're looking for is this UUID. All right, so I'm going to select that number right there, right-click copy, and finally I'm going to type in nano space /etc/f/stab. Okay, and here is our fstab file. So editing this is pretty straightforward. What we're going to do is type in the following command to add this one. So first one will be UUID equals, and then you're going to paste in that UUID. All right, and then put tab. Next, you're going to put the location for it, which will be /media/SSD. Another tab. We're going to put in our file type, our file system type, which is ext4. tab, and I'm going to type in UID equals 1001, comma, RW for read write, comma, users, tab 0, tab 2. And then to save this, just hit Control S and then Control X. And all that's left to do now is to reboot your Raspberry Pi, and then we'll check and see if it automatically mounted our SSD. After your Raspberry Pi reboots, then what we'll want to do is see if we can access that media folder. So log back into your Raspberry Pi and then type in cd space /media/SSD. And then type ls, and there it says lost plus found. That means that we are definitely in our SSD, and it should be accessible to Flux. Now, before we install the FluxOS, we're going to need to make sure that we forward the proper ports on our router. And I'm over here on Walter's guide, step number 5, configure your router to work with Flux. And it goes through all of the different port numbers that we need to make sure we forward these over to our Raspberry Pi. And that also goes into port 22 if you want to be able to access your Raspberry Pi from outside of your home network. Now, I don't usually recommend opening up port 22 because there's a bunch of bots on the web that are constantly searching around for computers that have port 22 open, and they may try to log into your machine. So it's probably safer not to open that port up on a home connection. It would be even safer if you had a separate router dedicated just for this setup, right? And you don't use that router for your home network. You should really isolate things as much as you possibly can. But that being said, we have firewalls set up on the software end of things, and we're only going to open up the ports that we absolutely need for Flux right now, okay? So with that out of the way, how do we make that change in our router? It would be beyond the scope of this video to try and show you how to do this on every type of router in the world. So you're going to have to do some research to figure out how to log into your router's dashboard and then how to change your port forwarding settings. I'm going to show you how to do this with my Linksys router. And to do that, I just click on Router Settings and then Security. And I'm going to click on Apps and Gaming, and then click on Single Port Forwarding. And for here, I'm just going to click on Add a new Single Port Forwarding, application name, and I'm going to put this as Flux 53 because I'm going to use external port 53. And the internal port will also be 53. Protocol is going to be both. And for our device IP, we're going to make that 192.168.1.106, and then I'm going to click on Save. Now we'll do the same for the next one. I'm going to call this one Flux 80. External port is 80, internal port is 80. All right, 192.168.1.106, and Save. Once again, add another one. This one's going to be Flux 123. External port is 123, internal port is 123. 192.168.1.106. Save. And one more for the single ports, and that would be Flux 443. And external port is 443, internal port is 443, and 192.168.1.106. Click on Save. Okay, great. So that's all our single port forwarding. Now we're going to switch over to port range forwarding. And it's asking me if we want to save. Say yes. Save those changes. Okay. And now we're on port range forwarding. And I'm going to click a new port range. All right, and that will be Flux D. And we're going to do 16124 to 16128. 192.168.1.106. And click on Save. All right, and lastly, one more range. We're going to add this, and this is going to be Flux Apps, and that will be 30, 1,000 to 39,999. And then we're going to make sure we put in 192.168.1.106. Click on Save and Apply. Okay, so now we have covered our single port forwarded addresses as well as our port ranges. We can click OK. And now our router has been set up properly for our Raspberry Pi to allow network access over those ports from the external web. Now we're ready to start installing software packages for the FluxOS. But before we can do that, we're also going to need to transfer over to our root user account. So once again, just type in sudo space su space dash. All right, that puts us in our root user account. Now we're ready to start installing software packages for the FluxOS. So to do that, I'm just going to go ahead and pull up this Medium post that has the whole guide on how we're to do this. And we're going to start by executing this command. So go ahead and select this, right-click and copy, and then we'll go back to our Ubuntu, and now we're ready to paste that here. So paste that command, hit enter. This will download the script file and run it. And now we're going to install Docker. Start with number 1. So put 1 and then enter. All right, and what this is asking us to do is to create a new username. So this will be the FluxNode user, all right, that really only applies for you, as this will be the account that you log into. So we're no longer going to log into the Ubuntu account. We're going to start logging into the new user account that we create here. So we're going to call this one whatever you want. I'll just call it Cumulus because this is a Cumulus node, and go down to OK. All right, it's created a new user, and now it's asking for a password. So make sure you choose a good password here and make it a secure one. Okay, everything looks good there. Now it's going to check the package repositories and start fetching all the packages needed for the installation of Docker. Great, now Docker's installed and it's asking if we would like to switch to our user account. So put a Y there for yes, and now let me clear that screen. We are logged in as the Cumulus user. And from here, we're going to need to go back to this article and copy that same command and paste it in one more time. All right, so now we're going to run this command as our new user, Cumulus. Hit enter on that. And we're ready to install FluxNode. So push number 2, enter. Okay, you're going to get a few prompts while you're going through this process, so hang tight and stick to the screen here. And the first question it's asking is, we're using port 22 for our SSH, and if that's correct, say yes. Now it's asking if we would like to create a swap file. Since we're using Raspberry Pi here, I'm going to say no, that's not necessary. If you have the Argon One Case, you'll see the little green light on the front of the case blinking, showing you that something's happening. But if you don't, then it may be tough to tell like what's happening right now. But all of the packages needed for the FluxOS are being installed in the background. You can't see what's happening, but sit tight with this because they have to download, and it takes a little bit longer to install files on an SD card, such as what we have in the Raspberry Pi. So just sit tight with this process and wait for the next question. Okay, packages are installed. Now it's time to configure our Flux daemon. And right now it's asking for our FluxNode private key generated by Zelcore. So to get that, we're going to go over here to our Zelcore wallet. And this is the wallet that I used to stake my collateral. So now I'm going to go over here to the apps menu and click on FluxNodes. And this should automatically detect my collateral now that I have it staked, right? So it came up right here as Cumulus. It says that it's offline. So if I click on this little down arrow here, I have an edit button where I can get some additional information. And what we're looking for is the private key. So I'm going to go ahead and click on that, which copies it to my clipboard. And then I'll jump back over here and I'm going to paste that in. So once again, if you're using PuTTY, just right click anywhere on the screen and that will paste whatever you copy into your terminal. Then I'll go down, OK. All right, now it's asking for our FluxNode collateral ID. So let's jump back over here and it says collateral TX ID is right here. Click on that one, same thing, copy it and jump back over and paste that in. Go down to OK. Now it's looking for our FluxNode collateral output index. So that is a 0. All right, so I'll go ahead and input a 0 here and go OK. All right, and that's going to create our daemon config file. All right, our next question is where we're going to download our bootstrap file. The bootstrap file basically downloads a copy of the blockchain so that you don't have to sync it block by block, and it really speeds up the process of getting your nodes synced. So I'm going to go ahead and choose option 1 to download from the script. After the bootstrap file is downloaded, it has to be extracted. So this takes the Raspberry Pi a little bit of time. Just sit tight. All right, next it's asking us if we want to remove that bootstrap archive file. And you know, since it really doesn't take long to download a new one, I'm not too worried about it. So I'm going to go ahead and say yes, and that will save us some space on our SD card. Now it's asking if the FluxNode is being installed on a VPS. And I'm going to say no, because this is not a VPS. It's a Raspberry Pi, and it's running from my home. So I'm going to say that, no. This next question is asking if we want to install a cron service for rotating IPs, which is required for dynamic IPs. Now, you'll have to do some research with your own ISP, your internet service provider, as to whether or not you have a static IP or a dynamic IP. Now, many home connections have some type of dynamic IP. In other words, it changes from time to time. It may be every month, maybe just randomly, but it will change. And if we set up Flux with a static IP and your modem gets a new IP from the ISP, then your Flux node will go off the network and you'll have to reconfigure it and it'll be a pain in the butt. What this is doing is it has a service that runs to see if the IP changes. If it does, then it will update that IP automatically so that you don't get booted off the network. So if you're running a Raspberry Pi from home, you're going to want to answer yes to this question. If you have a static IP, then say no. Okay, after a few more packages, it's time to add our Zel ID, and we're going to get that from Zelcore. So let's go back over here to Zelcore, and I'm going to cancel this and go over here to the apps button one more time and click on Zel ID. And from here, there's a little address right there. So just click that address. That'll copy our Zel ID. And we'll jump back over to here and paste our Zel ID in. Now, this is all so that we can log in to our Flux node through the web and then make adjustments to it, like restart the daemon or do benchmarking, stuff like that. Now it's asking if we're planning to run a Cadena node, and since this is a Cumulus tier, you cannot do that, so I'm going to say no. And now it is starting the daemon and syncing the chain, so just be patient. It's going to take about 3 minutes. Looks like the blockchain is still syncing, and you can see the local block height is the green number, and then the Explorer block height is the red number, and when the green number matches the red number, then we will be fully synced to the blockchain. Okay, now this spit out a lot of information, but I just want to scroll up again. Okay, this is just about complete, and right now it's spit out Flux benchmarks status running. So unfortunately, we don't have any information about our score for this node, at least not from the command line, but it also spits out some information about how to log into our node. So that's what we're going to have to do next to check our benchmarking and see what kind of score we got on that. So to access our node, there's a couple of ways we can do this. The first would be just copy this IP address and port number, or, which that might not work from your home address. You'll have to use your local IP. So remember the IP that you used to log into this? You'll have to use that one instead. But both of them should give you the Flux front end. So let's go ahead and try that out. All right, I'm going to start with the external IP, and works fine for me. Let's also swap out the external IP for our local IP. And that is giving us the same result. Okay, so your mileage may vary. You're going to have to figure out what works best for you. And I just want to make sure that you know there's those two options. You can use your external IP, but if you can't access that, then try using your local IP for the node. Next, we're going to want to log into this node using our Zel ID. So you would just go ahead and click on the Zel ID button here, and we're going to choose Zelcore, open that up, and then go ahead and sign this message. Okay, now that we're logged in, we can see our status. Flux is not confirmed. That's because we haven't started the node yet. But before I do that, I want to make sure that our benchmark results are what they need to be. So let's go over here to the left-hand menu and click on Benchmark, and then Benchmarks, and then Get Status. Okay, good. It says benchmarking Cumulus. So we got the right score. It was a little slow on the score. That might just be because Raspberry Pi, but here it is. It's what it's supposed to be. That means we can now start the node. So I'm going to go back to my home screen here and open up Zelcore. We can cancel out of this and go back to our apps menu, click on Flux Nodes, and then go over here to this little down arrow and click on Edit. And from here, I'm going to name this node. So I'm just going to call it Cumulus Pi. All right, I'm going to put in my external IP address here. All right, and click on Save. All right, so now we've got everything in as it needs to be. And I can click on the little Start button here. And this is just going to let me know that before we press start, we got to make sure that it's running and it passed all its benchmarks, which we just did. So everything looks good. Let's go ahead and start this node. All right, says it successfully started FluxNode Cumulus Pi. Now you can leave this open if you like, and it will just update every 1 minute or so. And yep, looks like already it says our Flux node started. That's great news. So there's that. If you want, you can also flip over to your front end here and just refresh this. And now you can see the status changed here too. So it says Flux has just been started. So after 1 or 2 more confirmations, this should be operating properly. You can also check status right inside the Flux Nodes app by clicking this little refresh button. And it just switched to confirmed. So let's jump back over to our front end and reload that. And there we go. Flux is working correctly. So now we are ready to start earning rewards in Flux. Wow. I know, that was a bit of a marathon, but we now have our very own Raspberry Pi running a Flux node. And as of the making of this video, we anticipate bringing in about 178 Flux, including parallel assets. So at the current valuation of Flux, that means we should just about break even on the hardware costs for our Raspberry Pi, the case, and the SSD, which is pretty sweet. So within the first 30 days, we have recouped our hardware costs. As for the ROI on the amount of Flux that you need to stake for a node, that's obviously going to take a little bit more time and your mileage may vary. Also consider that the more people who are running nodes within this tier will change the amount of rewards that you earn. So if there are more people, that means we'll be receiving less rewards per month. But nevertheless, this little tiny Raspberry Pi doesn't cost a lot to run. And if we get on it fast enough within the first month, we should recuperate our hardware costs. And then the rest of it is just passive income in terms of Flux. So I think that's pretty cool, guys. Let me know what you think down in the comments section. I hope you like this video. It took a long time to make this one, so please give me a thumbs up on this one. And be sure to subscribe and share this video with your friends, especially those people who might want to run their own Raspberry Pi FluxNode from home. Thanks so much for watching, and I'll look forward to seeing you guys in the next video. Peace.